Example number 3. We want to guess the value of the limit of sine of x over x when x approaches to 0. We notice that the function is not defined when x equal to 0. Now we just go ahead and plug in the numbers in the table for the x and we find the f of x. We see that plus minus 0.005 or plus minus 0.001, they are the one that close the most to 0. Give the answer is 0.9999. So this is almost 1. So we can say that the limit of sine of x over x when x approaches to 0 is equal to 1. In example number 4, we want to investigate the limit of sine pi over x when x approaches to 0. So we use x, the value of x is 1, 1/2, 1/3, 1/4, 0.1, 0.01. And we all see that the value of the y is all 0. So we may think the answer will be 0, but it is the wrong answer. Because if we look at the graph and we see that the function sine pi over x approaches to 1 and approaches to -1 when x approaches to 0. So when x go closer to the 0 on the left side or on the right side. So the answer is not 0, but is either -1 or 1. So we don't have exact answer. So in this problem, we do not have the answer for the limit. We would say does not exist. Example number 5, we want to find the limit when x approaches to 0 of x cubed plus cosine of 5x divided by 10,000. We first using the number x from 1 and then 0.5, 0.1, 0.05, 0.01. Then we see that number is really small and we may think the answer will be 0. However, if we make even x smaller, even x closer to 0, then these two numbers 0.05, 0.001 for the x value is give us the answer is 0.0001. So the final answer, the correct answer will be 0.001, or this is mean 1 divided by 10,000. So conclusion is that from example number 4 and example number 5, we may very easy to guess the wrong value when we use inappropriate values of the x. But it is very difficult to know when to stop calculating the values. So do not worry, because this section we are learning the limit by guessing. In the future, we will have the method how to calculate the limit.